Hi, welcome to the video on graph theory. My name is Hera Shaheen and today I am going to discuss some special types of graphs we use in graph theory. So, first of all, I'd like to tell you that I am making this video after a long time because I was busy with some family function, but now I will make the videos on a regular basis. Okay, so let's start. So this is first one is null graph. A graph having no edge and n vertices is called null graph. A graph having no edges and n vertices means they are having no edges, but it has some vertices. It can have one vertex, it can have two vertex, and I am denoting null graph as nm. nm. So this is V is vertices, E is edges, and degree D of V is degree of vertex. So suppose there are n vertices, but number of edges will always be 0. Since there are no edges, so degree of vertices will also be 0. Take some example. This is null graph having one vertex. Okay, so this is example of this. This is one example. Set another example having two vertices but no edges. This graph has two vertices but no edges. Another example I am taking. Third example, three vertices but no edges, and so on. Okay, in null graph you can have n vertices but there will no edges. Okay, that is called null graph. Now we'll see another special type of graph which is known as cycle graph. Okay, so which is known as cycle graph. What is cycle graph? Cycle graph is a simple graph with n vertices. Cycle graph is a simple graph with n vertices v1, v2, v3 to vn. Okay, and edges will be from v1 to v2, v2 to v3, v3 to v4, v4 to v5, and so on, vn minus 1 to vn. And vn to v1 will be also be one edge. Let's see first its definition. That cycle graph is a simple graph with n vertices v1, v2, v3, v4, v5 dot dot to vn, and edges v1, v2, v2, v3 dot dot vn minus 1 to vn and vn to v1. Okay, so these are edges v1, v2, v2, v3, vn minus 1 to vn, vn to v1. So this will make a cycle. Let's take one example, C3. C3 denotes that we are having a cycle graph of three vertices. So these are three vertex v1, v2, v1, v2, v3, and there is an edge from v1 to v2, from v2 to v3, from v3 to v1. So this is a cycle graph of three nodes or three vertices. Same nodes or vertices are same. Let's take one graph, cycle graph of four vertices. These are four vertices v1, v2, v3, v4. So we are having edges of from v1 to v2, v2 to v3, and v3 to v4, and again v4 to v1. So this is a cycle graph of four vertices. C5 is the cycle graph which having five vertices. This is the graph v1, v2, v3, v4, v5 are the vertices, and there are edges between v1 and v2, v2 and v3, v3 and v4, v4 and v5, and then again v5 to v1. So this is a cycle graph which is containing five vertices. So what you see that the number of edges present here are as many as number of vertices. Here, look at here. How many edges are there? 1, 2, 3, 4, 5, and vertices how many? 5. So in a cycle graph, how many, if Cn is a cycle graph containing n nodes, then vertices will be n, number of vertices will be n, number of edges will be n, but degree of each vertex will always be 2. In a cycle graph, degree of each vertex will always be 2. One thing you must remember in this cycle graph, that if in any cycle graph if you remove any one edge, at least any one edge from this graph or cycle graph, then your cycle graph will become tree. Then that graph will not be cycle graph, then that graph will become tree. But if you try adding one edge to that tree, it is not necessary that that graph will become cycle graph. Okay, for example, this graph C5, we are removing this edge V1 to V5 or any edge. Okay, so it will become like this, like this. So it is not cycle graph now, it has become tree. And now if we try to add one edge to this graph, but we don't know where we have to add, then that graph will become, it is not necessary that the graph will become cycle. You can add here, so sorry, you can add here, you can add here, you can add here, you can add here. You are adding one edge, but it is not necessary that that graph will become cycle. Now we'll see another type of graph which is known as complete graph. So first of all we see what is complete graph. A complete graph is denoted as Kn. Okay, K is for complete and n is for number of vertices. So this Kn is a complete graph of n vertices, is a simple graph in which every pair of vertices are adjacent. Okay, so in which every pair of vertices are adjacent, means all the vertices are connected with all other vertex in the graph. Suppose there are only one vertex in your graph, like this one. This is called K1. So since there is only one vertex, so there will be no edge. Okay, in K2 there are two vertices, and this vertex should be adjacent to this, means there should be one edge between them. For K3 you have three vertices, and one vertex will be adjacent to other two vertex. This vertex is adjacent to this two vertex, and this vertex is adjacent to this two vertex. Means one vertex will be adjacent to all other vertex. Suppose there are n vertices, then one vertex will be adjacent to n minus 1 vertices. So now take example of 4 vertex K4. So here these are 4 vertices, 1 2 3 4, and all are adjacent to each other. Okay, so this is connected, this is connected, these are connected, this two also connected, this two also connected, and this is also connected. You can see here like this, that take this vertex and you are connecting this with this, this with this, this with this. Every vertex is connected with all other vertices. Okay, leaving that vertex, it is connected with this one, it is connected with this one, it is connected with this, and every vertex is like this, likewise connected. Okay, so now take K5. K5 means you are having complete graph of 5 vertex. So these are 5 vertices, and this every vertex like this one is connected with all other 4 vertices. Since this is K5, so it will be, one node will be connected to all other 4 vertices. 1 2 3 4. This is here one vertex, one edge, this is one edge, this is one edge, this is one edge. So there are 4 edges coming from this node, and likewise all other vertices. So this will be called complete graph of 5 vertices. Okay, now this is a table of complete graph containing 1 vertices k1, complete graph of containing 2 vertices k2, complete graph of 3 vertices, complete graph of 4 vertices, complete graph of 5 vertices. So in k1 number of vertices will be 1, in k2 number of vertices will be 2, in k3 number of vertices will be 3, in k4 number of vertices will be 4, k5 number of vertices will be 5. Number of edges will be in k1 will be 0. Number of edges in k2 will be 1. Number of edges in k3 will be 3. Number of edges in k4 will be 6. Number of edges in k5 will be 10. You can count. I have drawn the graph earlier just now, so you can see there also, or you can count there the how many edges are there. And degree of each vertices will be, in k1 degree of vertex will be 0, in k2 degree of vertex each vertex will be 1, in k3 degree of each vertex will be 2, in k4 degree of each vertex is 3, in k5 degree of each vertex is 4. So what you see, that what is degree? Degree is 1 less than number of node. Here number of nodes are 1 2 3 4 5, degrees are 0 1 2 3 4. Okay, so you can, if you are asked to tell that how many what will be the degree of each node in complete graph of having n vertices, then that the degree will be n minus 1 of each node. Okay, so but if you are asked to find the maximum number of edges in a simple graph with n vertices, what will be your answer? Your answer will be NC2. How? Because n is the number of vertices and each 2 vertex can make an edge. I have done this thing that the maximum number of edges in a simple graph with n vertices is NC2, which is n into n minus 1 by 2. Okay, now here is a table for complete graph Kn. Vertex will be n denotes vertex, and E is the number of edges. So number of edges will be NC2, n into n minus 1 by 2. You can find this using this formula, NC2 n into n minus 1 by 2. Suppose for K5. So this will become 5 into 4 by 2 means 4 by 2 means 2. 5 into 2 is 10. So number of edges will be, in K5 number of edges will be 10. And degree of each vertex will be n minus 1. It is n into n minus 1 by 2. Okay, or here degree of each vertex will be n minus 1. This is in general. Okay, so you must remember this formula, this one, that the maximum number of edges in a simple graph with n vertices will always be NC2. This is maximum number of vertices, means there cannot be more vertices than this. In any graph, if there is n number of vertices, then the number of edges, maximum edges will be NC2, that is n into n minus 1 by 2. So you make a note of it, that this is very important. So maximum edges in a simple graph will occur only in case of complete graph. If a graph is complete graph, then only the maximum number of edges will be present in that graph. Okay, so because every pair of vertices are adjacent in case of complete graph, that is why in complete graph the number of edges will be maximum, and in no other graph the edges will be maximum. If the graph is complete, then only the number of edges will be your maximum. Okay, so let's take 3 vertices. Okay, so with 3 vertices, how many graphs are possible? Let's see. With 3 vertices, for one graph is this is known as null graph, other is with 1 edge, and the other is with 2 edge. With 1 edge you can have 3 graphs possible. Okay, this is a graph with 3 nodes, but only you have one edge. This is a graph with 3 nodes, but there are no edges. In this graph there are 3 nodes, but you have one edges. This and this, these 3 graphs are having one edge only. Now this graph is having 2 edge. Now we can see that this is also one way of having 2 edge, and this is also one way of having 2 edge. Okay, so and now you can have 3 edges also in your graph, like this. So how many graphs are possible now? Count it. This is one graph, this is second, this third, fourth, fifth, sixth, 7, 8. So with 3 nodes you can have 8 graphs possible. 8 graphs possible. How you can find this thing? Because let us denote these edges as A, B, C. Okay, and each edge have 2 possibility. Either they can be present or they are not present. Either they can be present or they are not present. A, B, C, and every node has 2 possibility. This has 2 possibility, this has 2 possibility, this has 2 possibility. What are the 2 possibilities? Either they can either present or not present. So when you are asked that how many graphs can be possible with 3 nodes, then what you have to do, you have to multiply the possibilities of these. So it will is 2 into 2 into 2 is 8. So 8 graphs are possible with 3 nodes. With 3 nodes 8 graphs are possible. How? If there are no edges, then this is one graph. If there is one edge, then there can be 3 graphs, this one, or this one. Okay, so these are 3 graphs. And when there are 2 edges, then this 1, 2, 3, these are 3 graphs having 2 edges, and this is one graph having 3 edges. So how many graphs are possible with 3 nodes? 8 graphs are possible. How it is calculated? Using this. Okay, we have to write the edges and their possibilities we have to note, and we'll multiply with this, multiply all these possibilities, and it is 8 graphs are possible. So it means each edge has 2 possibility to be present in the graph. With n vertices, maximum number of edges possible is nc2, that is n into n minus 1 by 2, and edge has 2 possibility, either it can be present or it cannot be present. So what I mean to say, that each edge, suppose there are how many number of edges? N into n minus 1 by 2, then 2 into 2 into 2 till n into n minus 1 by 2 times, isn't it? How many times it will be? It will be n into n minus 1 by 2 times. If suppose you don't know how many edges are there, and if you are asked to find the number of graphs possible, okay, you are only told that there are n vertices, then how many graphs are possible? With 3 vertices we are saying that 8 graphs are possible. Then if there are n vertices, then number of edges will be, maximum number of edges will be n into n minus 1 by 2, and each edge has possibility 2. So 2 into 2 into 2, then the total number of graphs possible will be 2 into 2 into 2, because every edge has possibility of 2. Then we will multiply it, so it will become 2 to the power of n into n minus 1 by 2. So total number of graphs possible will be 2 to the power of n into n minus 1 by 2. You write it down. Total graphs possible, 2 to the power of n into n minus 1 by 2. To the power of n into n minus 1 by 2. Okay. And that's all for today. We'll see bipartite graph in the next video. If you like my video, don't forget to hit the like button and subscribe my channel and share with your friends. And if you have any query, you can ask in the comment section, or you can write in the discussion forum also. Okay, thanks for watching.